Today we're going to discuss how to take what we've already learned about trigonometry and angle measures and relate that to the unit circle. So the first thing we want to think about is this definition of unit circle. So the unit just means a radius of 1 unit. And we can then use this idea of the circle. We can change the radius length, but we still have all of these infinite points along the outside of this circle that we can assign an ordered pair. Now, we know that ordered pairs on the coordinate plane relate to x and y. Sine, when you think about sine from right triangle trigonometry, we know that the sine of an angle is equal to the opposite side to the angle divided by the hypotenuse. So on this picture, we've created our unit circle. We have this single point here that we've labeled x and y. We have our radius that starts here at the origin, and we're opening up to this angle. We've called this theta. So theta is a Greek symbol. And as you study the unit circle more and get into higher level maths, you'll use the Greek alphabet to label angles. So things like theta, alpha, and beta are probably the most commonly used. So this angle theta that is opening from, again, our initial side, which is on our x-axis, and then opening to our line where the radius is. So what we're going to think about is that if this is my angle, how far am I traveling along the x-axis to get to that point? So no matter where that angle is, I'm going to move x units from here to here. And then to travel my vertical distance, so that's your horizontal is your x, your vertical distance is y. And so that is your opposite side of that right triangle from your angle. So we would say the sine of that angle theta that we opened up, the opposite side is y. And your hypotenuse, because this is a right angle here, is going to be r. So the sine of any angle that I put on this circle is going to be equal to y, which is our vertical displacement to get to that point, over the radius of our circle. Now, we're going to go back to a unit circle that my radius here is 1. So if I change or substitute r as 1, on the unit circle, all of my y coordinates are going to be equal to the sine of that angle. And remember, that's the ratio of those two side lengths together. We can think about the same thing for cosine. Cosine is equal to the adjacent side to the angle divided by the hypotenuse of the right triangle. So our cosine is going to be our horizontal displacement, which is x, however many units I'm moving to get to that point, over the hypotenuse, which again in that right triangle is equal to the radius. If I make that equal to 1, that means that all of the x values for those ordered pairs on my unit circle are going to be equal to the cosine of theta. So what we've proven is that x is equal to r times the cosine of theta, which in our case in the unit circle is 1, and that y is equal to r sine of theta, again r is equal to 1. And that means that the ordered pairs on the unit circle can all be written as cosine of theta for x and sine of theta for y. And then we're going to use these values to evaluate sine and cosine values at all of these special angles that make up what we refer to as the unit circle. Before we go into our special angles, we're going to take a second. We have to review our special right triangle ratio, because all of our angles that are on the unit circle are going to be either 45, 45, 90 or 30, 60, 90 special right triangles. So remember that for a 45, 45, 90, we have an isosceles triangle, which means that our legs are going to have the same measure, and our hypotenuse is always going to be the length of that leg times radical 2. So we have the two legs, and we have the hypotenuse. So if my leg had a length of 2, the hypotenuse is going to be that number times radical 2. We can also work backwards. Let's say that the hypotenuse had a length of 2. So to work backwards to the short leg, I would have to divide the hypotenuse by radical 2. And then we previously talked about rationalizing. So I don't want that radical in the denominator. So we multiply by that radical divided by itself. And we're left with just the square root of 2. Our other special right triangle was a 30, 60, 90. So in a 30, 60, 90, we have two legs with different lengths. So one of those is referred to as the short leg. We have the long leg. And then just like every other right triangle, we have the hypotenuse. Now your short leg is always going to be opposite of the smallest angle, which in this case is 30. Your longer leg is the middle length, which is 60, or from the middle angle measure, which means that to go from the length of the short leg to the long leg, we take the length of the short leg and multiply it by radical 3. And then our hypotenuse is always opposite the 90, and it's going to be 2 times the length of the short leg. So if they told us that we had a 30, 60, 90 triangle, and our short leg was 3. To get the long leg, we just take that number and multiply it by radical 3. And to get the hypotenuse, we take the short leg and double it, so it's 6. Now the reason that these are important is because we said that all of our angle measures on the unit circle are going to be multiples of either 30 or 45. We're only going to focus on the video on the first quadrant. We're going to talk about second, third, and fourth in class together. So again, if we're thinking about measuring angles, we start at 0 degrees or 0 radians with our initial side. The first angle we have here is 30 degrees. Then we have 45. Then we go to 60. And 1/4 is going to put us at 90. Now we're also going to talk about this in terms of radians, but again, I want to do that in class with you. So we're going to just use our degree measures today in the video. And what we think about is if I have a 30-degree angle and I create that right triangle that we were thinking about before, and I'm in a unit circle, I know that my radius is 1. So this angle that's opening up here is 30 degrees. That puts me at the 30 degrees mark here. And we want to think about where would that order pair be? Well, I can use the sides of this right triangle to help me figure that out. The short leg across from the 30 is going to be half of the hypotenuse, so this is going to be 1/2. And then we take the length of the short side and multiply it by radical 3 to get the length of the longer side, which is opposite of 60. So I've put these two sides of that triangle in. Well, that's the distance that I'm moving away horizontally and vertically. So if I'm moving horizontally, radical 3 over 2, that would also be the cosine of that angle in that triangle, because that's the adjacent side divided by the hypotenuse. And I'm moving vertically 1/2, because again, that would be the sine of that angle, 1/2 divided by 1 is just 1/2. So the ordered pair at 30 degrees is radical 3 over 2 and 1/2. Radical 3 over 2 again is your cosine. Your x value is your cosine. Your y value is the sine of that angle. If we think about a 45-degree angle, again, the radius length is not changing here, which means the hypotenuse is still going to have a length of 1. So if we draw in our right triangle, I just have to figure out what these two side lengths are here. Well, we know that whatever the leg is multiplied by radical 2 is going to equal the hypotenuse. So we can divide by radical 2. I don't want that radical in the denominator, so we're going to multiply by radical 2 over 2 to rationalize. So this is radical 2 over 2. So my order pair and cosine and sine values for a 45-degree angle are the same at radical 2 over 2. Now the nice thing about the 60-degree angle is we've already solved for the 30, 60, 90 angles. They're just switched because our horizontal distance here, now we're opening up to a 60-degree angle. So those values just flip. So this is going to have a cosine value of 1/2 and a sine value of radical 3 over 2. The other angles that we want to think about are 0 and 90. So if I'm moving out to this point here along the x-axis, again, that represents the radius of that circle. It's 1 unit away. So on the axis, that point would be at 1 on the x-axis, and I didn't move anywhere on the y-axis. At 90 degrees, I haven't moved anywhere along the x-axis, but I've moved vertically 1 unit. So all of our points on the axes are also going to be assigned values as angles. The last thing that we want to talk about is an identity that's called the tangent. So you learned about tangent with right triangles. The tangent of an angle is equal to the opposite side over the adjacent side. And here we know that cosine is our x value and sine is the y value. So we can just do some pretty simple substitution here. If this is my angle, we can start with just our vertical and horizontal displacement. The opposite side is y. The adjacent side is x. And we know that those are equivalent to the sine of that angle and the cosine of that angle. So an identity just means that we know that this statement is always true. These two things are going to be equivalent, and we can substitute values. So if we were going to find the tangent of an angle, we would take the sine of that angle and divide it by the cosine. So let's say, for example, that we wanted to find the tangent of 30 degrees. Well, from our previous problem, we know that at 30 degrees, our sine, which is our y value, is equal to 1/2. And we know that our cosine value, which is x, is equal to radical 3 over 2. And we can simplify that. So we multiply by the reciprocal. That cancels that denominator. Don't want that radical there. So we're going to multiply and simplify by the denominator divided by itself. And then now space here, so this is going to be radical 3 over 3. So again, we'll talk more about the tangent and sine and cosine together in class, but that is your introduction to the unit circle.